Okay, in this lesson we're going to talk about how to use quadratics for real world type problems and basically how to write equations of quadratics based off of a word problem. Alright, so looking at number 1, it says the amazing Larry is a human cannonball. He would like to reach a maximum height of 30 feet during his next launch. Based on Amazing Larry's previous launches, his assistant DJ has estimated that this will occur when he is 40 feet from the cannon. When Amazing Larry is shot from the cannon, he is 10 feet above the ground. Write a function to represent Amazing Larry's height in terms of his distance. So first thing we're going to do is, using the graph, we are going to label the underlined parts from the story on the graph. Okay, so I highlighted the important information. The first thing, it says that he would like to reach a maximum height of 30 feet. Well, that point is right here. That's the vertex, and that height is 30 feet. And it says that he's going to reach that height when he is 40 feet from the cannon. So if we look here, the vertex is 40, 30. So the maximum height here is 30 feet, and he reached that maximum height when he was 40 feet from the cannon. Then it says when Amazing Larry is shot from the cannon, he is 10 feet above the ground. So that's that point right here. That's his starting point, and that's the y-intercept, and the coordinates of that point is 0, 10. So this is the initial height, and this right here is the maximum height, which we know is the vertex. Okay, so based off of that information, we should be able to write the equation. So it says, in which form should we write the function and why? Well, in this problem, we're given the vertex, and if you're given the vertex, that means you should write the equation in vertex form. So this vertex, this is h, and this is k, and we're going to use that to find the equation of the graph. Alright, so determine the function f of x for Amazing Larry's height in terms of his distance. So vertex form is like this: f of x equals a x minus h squared plus k. So what I'm going to do is I'm going to plug in the information that we know. Well, we know our vertex, h and k, so h is going to be plugged in for h, and k is going to be plugged in for k. And in addition, we are given another point, which is the y-intercept. Well, this point, we're going to plug that in for x and y, or f of x. So y and f of x are the same thing. So we're going to plug this in for x and y. So my starting point, we're going to plug in for f of x, and then we are going to plug in 0 for x. This will allow us to solve for a. So writing our equation in vertex form, we have f of x equals a. So I'm just going to plug in the obvious stuff. So it's x minus 40 squared plus 30. Remember, the sign switch for anything inside the parentheses. So now I'm going to plug in my f of x and my h. So f of x is 10, so it's going to be 10 equals a, x is 0, plus 30. So now we're going to solve for a. So at this point, we're plugging in other point to solve for a. So the other point is 0, 10, and this is x, and we plug this one in for f of x. Okay, so simplifying this, we get 10 equals a, 0 minus 40 is negative 40 squared plus 30. And then simplifying further, negative 40 squared is 1600. So this part is the 1600 plus 30, and now it just becomes a pretty simple two-step equation. We're going to subtract 30 from both sides. So I have negative 20 equals 1600 a. And to get a by itself, we're going to divide both sides by 1600. So we get a equals negative 0.0125. And a should be negative. That's what you would expect considering this is concave down. So once we have a, what we're going to do is we're going to plug that back in for a in this equation. So we're going to take this and we're going to plug it back in to write the equation. So it's going to be f of x equals negative 0.0125 and then x minus 40 squared plus 30. And there's the equation. All right, let's look at another example. All right, so this one we're going to have to draw a picture, but it says Charlie runs for 10 feet and then kicks a soccer ball into the air. It lands 100 feet from him. When the ball is a horizontal distance of 80 feet away, the ball is 40 feet in the air. Sketch a picture below and label the important parts of your graph. Okay, so basically the graph is going to look like this. He runs for a little bit, he kicks the ball, and then the ball lands. Okay, so what I'm going to do is label these important parts. So first of all, he runs for 10 feet, and then he kicks the ball. So what we're doing is we're graphing the flight of the ball. So if he runs for 10 feet, and then he kicks it, this is the point that he kicks it. So this point is 10, 0. Okay, then it says it lands 100 feet from him. Well, if this is where he's kicking it, 100 feet from him might be somewhere right here. And 100 feet from the 10 feet, the coordinates of this point isn't going to be 100, 0. Remember that he ran 10 feet. So this is going to be 110, 0. So let me just highlight what we have. So when he runs for 10 feet and kicks a soccer ball in the air, that's this point. And then it landing 100 feet from him, that's this point. Then it says when the ball is a horizontal distance of 90 feet away from him, so again, he is right here. This is where Charlie is. 80 feet from him is going to be right here, and 80 feet, if this is 80, that means this point is going to be at 90. The ball is 40 feet in the air, so I'm just going to put a dot where the ball would be. This is 40 feet. So 80 feet from him, 40 feet in the air. That means the coordinates of this point is going to be 90, 40. So we don't know anything about that point other than it's just a point on the parabola. It doesn't necessarily mean that that point is the vertex, though it might be. If it doesn't say it's a maximum height, it's not the vertex. So horizontal distance of 80 feet away from him, so that's where the 90 comes from. It's 40 feet in the air, so that's where the 40 comes from. Okay, so now I'm just going to sketch the actual graph. So it should look something like this. It doesn't have to be a perfect graph. So now we have all the coordinates, where he kicked the ball, where the ball landed, and then where the ball is after a certain point in time. So because we're given the x-intercepts, we should be writing this one in factored form. Okay, so in factored form, our equation is going to look something like this. It's going to be f of x equals ax minus r1, x minus r2. So first of all, let's plug in what we know. Well, we have our two x-intercepts. We have 10, which we'll plug in for r1, and then we have 110, which we'll plug in for r2. And we're going to plug that in first. So we have f of x equals a, and then we have x minus 10 and x minus 110. Then, just like in the previous problem, we need to use this point which we're going to plug in for x and f of x, or for x and y. So plugging in f of x, so this f of x for this f of x, and then we're going to be plugging in 90 for x. Then we can work backwards to solve for a. So plugging that in, you get 40 equals a times 90 minus 10 and 90 minus 110. So simplifying this, you get 40 equals a, 90 minus 10 is 80, and 90 minus 110 is negative 20. So 80 times negative 20 is negative 1600 a, and then to get a by itself, we're going to divide both sides by negative 1600. You get a equals negative 0.025. So once we have that, we're going to plug in to original equation. So taking this, we're going to take this and plug it in there for a. So our equation is going to be f of x equals negative 0.025 x minus 10 and x minus 110. Alright, so then C says, what is the x value of the vertex? How do you know? So if you remember to the previous lesson, we learned how to find the axis symmetry, or the x value of the vertex, using our intercepts. And remember that we can just add our intercepts and divide by 2 to find the middle. So for this one, it's going to be x equals, and then we're going to add 10 plus 110 divided by 2. So that's 120 divided by 2. That's 60. So the x value of the vertex is 60 because it's halfway between the x-intercepts. So then we can use this information to answer part D, where it says determine the maximum height. So remember, the maximum height happens at the axis of symmetry, which we found in the previous one. So what we're going to do is we're going to plug 60 into our equation. So f of 60, and we're going to plug that into this equation right here. So we're going to take 60 and plug it in for x right there and there. So it's going to be negative 0.025, 60 minus 10, and 60 minus 110. So if you put that in your calculator, you get 62.5. So writing my answer as a sentence, the maximum height of the ball is 62.5 feet. Alright, now let's take a look at this last example, which is a U-try that we did in class. So it says, Mitsu shoots an arrow from an initial height of 2 meters. The arrow reaches its maximum height of 20 meters after it has flown a distance of 60 meters. Sketch a picture below and label the important parts of your graph. Okay, so first of all, we have the initial height of 2 meters, meaning that is the starting point. So the coordinates of my starting point is going to be 0, 2. We also know the maximum height and when it occurs. So it says it has a maximum height of 20 meters after it has flown a distance of 60 meters. So this is distance and this is height. So the coordinates of this point is going to be 60, 20. Alright, so it's going to look something like this. We don't know where it lands. All we know is that this is the maximum height, which is the vertex. and this is the initial point. So this is going to be h and k, and then this is going to be x and f of x, or x and y. So for this one, we're going to write this one in vertex form because, well, we're given the vertex here. Okay, so writing it in vertex form looks like this. It's f of x equals a times x minus h squared plus k. All right, so first of all, plugging in our vertex, we have h, which will plug in there, and we have k, which will plug in here. So our equation is going to look something like this. F of x equals a times x minus 60 squared plus 20. So in order to write our equation, we have to solve for a. So this is where this other point comes into play. We're going to plug in 0 for x, and then we are going to plug in 2 for f of x, and then we're just going to work backwards. So this is going to be 2 equals a times 0 minus 60 squared plus 20. So simplifying here, 0 minus 60 is negative 60 squared. Okay, simplifying this a little bit more, we do the exponent. So negative 60 squared is 3600a. And then we solve. Subtract 20 from both sides. So this is negative 18. And then to get a by itself, divide both sides by 3600. So we get a is negative 0.005. So once you've solved for a, we basically just need to take that and plug that back in for a up here. So we're going to take that and plug it in. So my equation is going to be f of x equals, we now have a, negative 0.005, and then it's going to be x minus 60 squared plus 20. So whenever you write your equations, the only numbers that you should have in your equation is just, the only letters you should have is x. Everything else should be a number. Okay. So then it says, determine the height of the arrow after it has flown a distance of 100 meters. So all we're going to do here to find this is we're just going to plug 100 in for x. So we're going to do f of 100, and we're going to plug it into this equation that we found in the previous problem. So it's negative 0.005, 100 minus 60 squared plus 20. If you put that in your calculator, you should get 12. So the height of the arrow after it has flown 100 feet or 100 meters is 12 meters. Alright, now I'm going to go over number 2, which is on the practice problem. It says, Hector's dog Ginger completes in a waterfowl jump. She runs for 3 feet to the edge of the water and then jumps and catches a toy duck at a horizontal distance of 10 feet from the edge of the water and a height of 2 feet above the water, and lands in the water at a horizontal distance of 15 feet from the edge of the water. So first thing we're going to do is we're going to sketch a picture. So first of all, this is similar to the second problem that we did. The dog basically runs for a little bit and then starts jumping. So this is the point where Ginger jumps, and she ran for 3 feet, which means the coordinates of this point is 3, 0. Then it says she jumps and catches a toy duck at a horizontal distance of 10 feet from the water's edge. So if this is the water's edge, 10 feet away, this point would be 13, and the height is 2 feet above the water. So that's the y value. There's 2 feet above the water. So this point is 13, 2. So the reason why it's 13 and not 10 is because, remember, she ran 3 feet first. So that's why we do 3 plus 10. That gets us to 13. Okay, so there's the second point. And then it says that she lands in the water as a horizontal distance of 15 feet from the edge of the water. So if this is where she started her jump, 15 feet from her, we would add 15 to that. So where she lands is somewhere right here, and 15 plus 3, she lands at this point. So this point is 18, 0, because she lands 15 feet away from her leaping point. So here's our graph. It looks something like this. And again, this point right here is not the vertex. It's only the vertex if they say it's a maximum height. All right, so in this problem, we're given our x-intercepts. It's basically the leaping point and her landing point. So since we're given her x-intercepts, or since we're given x-intercepts, that means we're going to write it in factored form, because we have the x-intercepts. All right, so now we're going to write the equation. So if we're writing it in factored form, it's going to be f of x equals a, and then x minus r1, and x minus r2. So here's r1 and here's r2. We're just going to plug that into our equation. So it's f of x equals a, and then x minus 3 and x minus 18. So to solve for a, we're going to use our other point. So we have this point right here. This is going to be our f, our x, and our f of x. And we're going to take that and we're going to plug it in. So we're going to plug in x for x, and then we are going to plug in 2 for f of x. So our equation is going to be 2 equals a times 13 minus 3 and 13 minus 18. So simplifying things here, we get 2 equals a, 13 minus 3 is 10, 13 minus 8 is negative 5, and then we multiply. 10 times negative 5, that's negative 50a. To solve, divide both sides by negative 50, and you get a is negative 0.04. So once you have that, we're going to take that and we're going to plug it back in for a. So now that we've solved for a, we're going to take that and plug it back in right there. So my equation is going to be f of x equals negative 0.04, x minus 3, and x minus 18. Okay. So then it says determine Ginger's maximum height. So to determine the maximum height, we first need to find the axis of symmetry. And remember, the easy way to do that is just to find the midpoint between your x-intercepts. So our x-intercepts are 3 and 18. So we're just going to do 3 plus 18 divided by 2, which is 10.5. And then to find the actual maximum height, we have to plug in 10.5. So it's negative 0.04 times 10.5 minus 3 and 10.5 minus 18. You should get 2.25 feet. So the maximum height is 2.25 feet.